A variable is a piece of memory we use to store a value, in order to remember this value. But why is it necessary to remember anything? Well, when programming Odie, we can do a lot of stuff without having to remember anything. But introducing memory into our programs, that is, being able to remember things, we can do so much more. Furthermore, variables is a fundamental concept in programming in general. Without understanding and using variables, our programming skills are practically non-existent. To understand why variables are so important, recall this program from Lesson 3. When an obstacle appears in front of the sensor, Odie prints something on its display. This is the program responsible for this behavior. The problem we are now going to solve is the following: how many obstacles has Odie detected? Thus, our target is to enhance this program so that we store somewhere in our computer's memory the number of obstacles that Odie detected. Let us go to Snap for Arduino and start from the beginning, the variables category. You can see a lot of stuff here. Our first task is to create a variable, that is, to occupy a memory position in order to use it for storing a value. When you click the Make Variable button, a window appears, asking for the name of the variable. We usually give to a variable a name that reminds us the reason for creating it. In our case, we want to store the number of obstacles, so we name it number of obstacles. When we click OK, the variable is created and we can see it here. On the left of the variable, there is a checkbox. When it is checked, the variable and the value stored in it appear here. As you can see, Snap for Arduino has initially stored in the new variable the numeric value, 0. We can store any value in a variable by using this block. We select the variable into which we want to store a value, and then we write the value. On the right side of the word, to, we can place a numeric, alphanumeric, or logical expression. Here we store the numeric value 5 into the variable named number of obstacles. To execute the command, we click on it and then, the new value is stored into the variable. We can even store a logical value in the variable. Here, we store the value, true. And now, the value stored in the variable named number of obstacles becomes 0 again. Let us now return to our problem. Our task is to count the number of obstacles, and the word count is very important. How do we count? Obviously, we need to increase the number of detected obstacles by 1 each time a new obstacle appears. We can do this through this command, where the new value of the variable is set to be equal to the previous value of the variable, +1. Let us focus a bit more on this. If the value of the variable is not equal to 0, let us set it to 0 and execute the command. What happens is that the value of the expression on the right side of the word, to, is calculated. In our case, the value already stored into the variable is 0, so the value of the expression is 0 plus 1, which is equal to 1. This value is then stored into the variable on the left side of the word, to, and as a result, the value of the variable named number of obstacles is now equal to 1. Each time we click on the command, the expression is calculated again. The second time, the value of the variable is 1. Thus the value of the expression is 1 plus 1, which is equal to 2, and the new value of the variable becomes 2. The third time it becomes 3, and so on. We are now able to count, but not obstacles. We just count the number of times we clicked on the command. To solve our problem, we want this command to be executed each time a new obstacle is detected. This program is an attempt to solve the problem. We used a program from Lesson 3 and added a new command. In particular, if an obstacle is detected in sensor slot 1, the variable named number of obstacles is increased by 1. You may have already figured out why this program does not solve the problem. Executing it will reveal this fact. You see that the counter is increased not by 1 but by a lot each time a new obstacle appears. This is not what we had in mind. What causes this? Here you can see the forever loop of the program using a different notation. You can also see the variable named number of obstacles. Its value is initially set to 0. This loop runs fast, many times per second. Each time the logical expression inside the branch results to false, that is, there is no obstacle in front of the sensor, this is what happens. Then, at some point, an obstacle appears and the logical expression inside the branch results to true. As long as the obstacle continues to exist, the branch will continue to result to true, many times per second. Each such time, the variable named number of obstacles increases by 1. Assuming that the loop runs 100 times per second and the obstacle exists for 2 seconds, it follows that the counter will increase by 200 during the existence of the obstacle. This is not what we wanted. Here we show the same thing in a different way. The black circles correspond to the result of the logical expression inside the branch as time passes. When an obstacle appears, the variable increases by 1 each time the loop is executed. This is what we want to achieve. The first time the variable increases is okay because we have a new obstacle. But the rest of the times it should not increase because we still have the same obstacle. Therefore, our target is to allow the first increase per obstacle and somehow not to perform the rest of the increases. The question now is how to distinguish the good from the bad increases. The answer is simple. The good increase occurs after a true outcome that follows a false outcome. So each time we get a new outcome, we just need to remember the previous one. Or said otherwise, we should store each new outcome in a variable so that we are able to remember it when the next outcome arrives. Therefore, we need to use a new variable and we name this variable true before. We store logical values in this variable, and initially we set it to false, because initially no obstacle has arrived. Each time the loop runs, we store either true or false into this variable. To increase the number of obstacles, we need to check the value of true before, and this value corresponds to the outcome of the logical expression inside the branch during the previous run of the loop. Let us now explain what happens, in a way that is easier for everyone to perceive. Initially, and as long as no obstacle is detected, nothing happens. The true before variable is set to false again and again. Then at some point, an obstacle is detected. The logical expression inside the branch is now true and we reach the second branch. The true before variable is false, because it was set to false during the previous run of the loop. This means that the number of obstacles increased by 1, and thus becomes 1. We have now allowed the good increase to happen. Then, the true before variable is set to true. When the first branch is executed again, the obstacle is still there. Thus the outcome of the logical expression is still true. Then we reach the second branch, but this time, the true before variable is true. This means that the number of obstacles will not increase, and this will be the case as long as the obstacle is not removed, so that the true before variable becomes false again. It follows that we have now managed to avoid all the bad increases. When the obstacle is removed, the true before variable becomes false again, and we are ready to count the next obstacle. Time to go to Snap for Arduino and verify what we have seen so far. This is the program that counts the obstacles. Before the forever loop, we set the variables to the appropriate values. We have created these variables in advance. Here you can see the first branch, its logical expression, the actions if this expression is true and the actions if this expression is false. And here you can see the second branch. It does not have an else part because there are no actions in case that the logical expression is false. Now you see the program running. Clearly, we have managed to count obstacles. And we could not do that without understanding and using variables. See you in the next video lecture.